Yes, we're going to do another worded question in here. Remember that if you need to pause this video at any time, you should do that and make sure you don't move forward until you do understand what is happening. When we're doing worded questions, it's really important that you highlight what you deem as important when you actually read the question at the start. Marie's watering can is initially filled with 2 litres of water. However, the watering can has a small hole in the base and it is leaking at a rate of 0.4 litres per minute. Right there you can see that we've highlighted the important parts. So we know that the can had 2 litres of water. We know it was leaking. Right, so leaking would mean it is going down. It's minusing, so we use a subtract sign, and it's going down at a rate of 0.4 litres per minute. Question A says that we want to write a rule for the volume of water, V, in the can after T minutes. So T minutes and volume of water. We've actually basically already done this. So obviously we were working out the volume, and that's going to equal whatever's in the can. And it was 2 minus 0.4, and this said to use T for minutes. So right here you can see that we have designed our equation that we can use for the following couple of questions. This question here, B, says what volume of water remains after 90 seconds? To do this, we need to use the rule that we had at the start, which was V equals 2 times 0.4 T for minutes. What volume of water remains after 90 seconds? Remember that 90 seconds is obviously to do with the T minutes, and 90 seconds in minutes is 1.5. So 1.5 equals T. We're going to move this into our equation. V equals 2 minus 0.4 times 1.5. We can solve this algebraically or just whack it into our calculator, which is what I'll do now. So we go 2 minus 0.4 times 1.5, and it equals 1.4. So volume after 90 seconds is 1.4 litres that remains in the water can. So we've lost 600 mils. How long, so for the next question, actually not this one. How long would it take for all the water to leak out? So to do this, volume would have to equal 0. There's none left. So again, using our equation that we made at the start, all we're going to do is substitute volume for 0 because that's what it's going to be when it's all leaked out. So we'll go 0 equals 2 minus 0.4 T. From here we can solve this algebraically, or we can use the solve feature, and we're obviously solving for T. So we can put that into our calculator. Solve 0 equals 2 minus 0.4 T, comma, T. Hit enter and we'll see that T equals 5. So the time equals 5, meaning after 5 minutes all of the water has leaked out. To the next question, it's important we understand what we're trying to work out. If Marie fills the can with 2 litres of water at the kitchen sink, what's the maximum amount of time she can take to get her to the garden if she needs 600 ml of water to water her roses? So we know that she needs 600 mils. 600 mils is 0.6 litres, obviously. And that's what we're going to need for our volume. Again, using the formula or the equation that we created at the start, we can just substitute in what we're told, which will be 0.6 equals 2 minus 0.4 T, and T will give us the maximum amount of time she can take to get there. From here, we're going to use the solve feature for T. So basically this is the same as the last question. Instead of it being 0, it's going to be 0.6. So 0.6 equals 2 minus 0.4 T, comma T, and it says that T equals 3.5. So the answer for this, T equals 3.5, means that she can take 3.5 minutes to get to her garden, and that will ensure that she still has 600 mils left in her watering tin to be able to water her roses. Now these questions we can actually display on a graph. We don't have to because we're not asked to, but it is important to understand that we can display these on a graph. Now, in order to do it, we need it in the format y equals mx plus c. Our equation is not in that format because it is in 2 minus 0.4t. See how these two and these two are here, and our constant is actually on the wrong side. So we're going to need to flip these around, and these items are going to need to change. Remember that this is a positive 2. So this term here will need to go to the front of the equation, and this term here will need to go to the back. So when we look at it, we're going to rewrite it saying v equals minus 0.4t. This obviously all stays together, plus 2. Now that is in the format y equals mx plus c, where this is going to be our y-intercept and this is going to be our gradient. We can use this to put into a graph on our calculator, which I'll do now. So if we start a graph page, we want to insert an equation and a line, and remember it is minus 0.4 plus 2, because that was what we came up with. Now this graph can tell us a number of things. When x is 0, so the time is 0 at the start, y is quite clearly 2. So that's saying we've actually already answered that in one of the questions before. So at the start, there's 2 litres in here. This x-intercept we can also tell as well, and we've answered this question. When y is 0, remember y is the volume, so when there's nothing left, when there's no volume of water left, it crosses over the x-axis, and that is at 5. Now that sounds familiar to a question that we answered earlier as well. So after 5 minutes, we know that there's nothing left in here. We could actually answer the other question as well, and that was what happens when there is, how long will it take when we still have 600 mils left in here. Now to put that in, we need to insert a point on the line. So we go menu, geometry, points and lines, point on, and we are going to click anywhere. Let's just click in the middle, insert a line, and then obviously we're in the point on section, so we need to hit escape, and now we can move some things around. Now we want this point to say 0.6 on the y-axis, because we wanted 600 mils left in here, and see how long it's gone. So x-coordinate, y-coordinate, let's change the y-coordinate to 0.6, and we notice that the x-coordinate, or the time, is 3.5. Now that looks familiar to a question that we answered here. When there's 600 mils, or 0.6 litres, left in the can, it's taken 3.5 minutes, which is what it says here as well. From here we can change things if we're asked a number of questions. So after 2 minutes, there's 1.2 litres left in the can. After 1 minute, there was 1.6 litres, and so on. We can use the graph to answer a number of questions to do with this.